I am honored to introduce Solon Barocas from Cornell University, who researches bias in machine learning. He will be chairing our first panel tonight.
Welcome. Hi, everyone. It is also my distinct privilege and honor to introduce you to the first panel of the evening. I want to introduce the august panelist I have for you today. And so I'll start here to my right. This is Cathy O'Neill, mathematician, author, blogger, columnist. To her right is Deirdre Mulligan, associate professor at University of California, Berkeley. Moving down the panel, we have John Wilbanks, who is the Chief Commons Officer at Sage Bionetworks. And finally, Arvind Narayanan, Assistant Professor of Computer Science at Princeton University. So I'd like to just begin very quickly by saying that I think there's been a change in the past year, where there's a growing recognition that these systems, which we had hoped would be a mechanism to combat long-standing issues of prejudice and bias, as a way to really advance civil rights, are actually vulnerable to inheriting a lot of the exact biases that we thought these systems would help us overcome. And I think this has been an interesting thing to observe, where initial hopes about machine learning and artificial intelligence being a force for good, unquestionably, now I think being complicated by recognition that these things are actually very, very difficult, that they depend crucially on data produced by humans, evidence that reflects human behavior and culture. And as a consequence, that these things are in fact traps. There are real serious opportunities to replicate, to reproduce, and even possibly exacerbate long-standing issues of bias and inequality. And so I thought what I would do just to start is to ask the panelists to maybe reflect on what recent examples that we have of documented cases of bias in AI in the wild that can give us a concrete sense of what this might look like. So let's maybe start with you, Cathy.
Sure, and I'll do exactly not what you just asked me to do. I apologize, because I'm actually not going to do a documented case, but in fact a thought experiment, which I think is happening all over the world right now in the world of machine learning. But to say it's documented, and I'll get to why it's difficult to document this, and it's actually, I'll start there. It's secret. We can't get our hands on this. Even the people that are being targeted by these algorithms don't know they're being targeted. So the thought experiment I want to do with everyone in the audience, it comes from the world of Fox News. And I want to imagine, we all know that Roger Ailes was kicked out of Fox News after 20 years of harassing women. And I think it's fair to say, for the thought experiment, say that it was an environment where women were not encouraged to succeed. They would come and leave early because they were being harassed. They wouldn't be promoted appropriately or given raises. And the thought experiment is this. Let's imagine that Fox News decides to turn over a new leaf, and they replace their hiring process with a machine learning algorithm. Now, machine learning algorithms are touted as objective. They follow the numbers. They're fair inherently. But I want to do the thought experiment with you because it's actually going to show us not only that that's not true, but that a well-meaning professional data scientist doing their job as well as they can will unintentionally propagate bias. So here's what a machine learning algorithm is. It's taking historical data, looking for patterns of success, and that's defined by the person building the algorithm. And then it looks for patterns in the past that led to success in the past, and it just basically makes the assumption that that kind of pattern recognition is going to repeat in the future. So that might sound complicated, but it's actually not that complicated. If I were a data scientist hired by Fox News to build a hiring algorithm for them, I would look for the most relevant historical data, which would be, of course, the last 21 years of people applying to Fox News. And then I would say, look for patterns in that. I would be training an algorithm to look for patterns in that historical data for who was successful at Fox News. That's what a machine learning algorithm does. You train it on historical data, patterns to success. Of course, I would have to define success. And a reasonable definition of success for any company would be, say, somebody who stayed at least for 4 years, maybe, and was promoted at least once, or maybe given a raise. Something along those lines. A reasonable definition of success, a reasonable historical data set. And I would train my algorithm. And then I would apply that algorithm, now that it's trained, it's a professional machine learning algorithm, right? I would apply it to a current pool of applicants. And then the question for the audience is, what would happen when I do that? And I set it up, it's Fox News, it's not just any company, right? It's Fox News. I set it up so that you'll see that the women in the current pool of applicants would be filtered out by that machine learning algorithm because they do not look like people who were successful in the past. And remember, all machine learning algorithms do is recognize patterns. Recognize patterns. So if they're looking at a woman applicant, a qualified woman, they'd be like, oh, people like her, when they were hired, did not become successful, statistically speaking. So that would be a sense of propagating bias in the past. Not only would it be propagating, as Solon mentioned, it sometimes exacerbates past practices, right? And in this case, I think you could argue that if we trust machine learning algorithms blindly to be fair, when they're not actually fair, when they're actually propagating old bias, then what we fail to do is scrutinize that process, that new hiring algorithm. So what we're doing is we're actually doubling down on it. We're saying, yes, it says we don't happen to know this, but it is actually as biased as the past practices were, but we trust it as well, and we don't scrutinize it. And so that's where the real problem with machine learning comes in. Not that it creates problems and bias, but that we don't know about that bias, and we tend to think of it as just the way things are, and we don't question it. And that's what we need to start doing.
Thanks, Cathy. Deirdre, please.
Sure. So an example that has gotten a fair amount of media play was the North Point Compass system, which, despite the fact that it was a different system that Cathy just described, suffered from many of the same issues about perpetuating historical biases in policing practices or sentencing. But the thing that was so interesting about it, from my perspective, is that it is a system that is being acquired by government to do its work. And when we think about government decision-making, we are really cognizant of the sort of power that it yields, right? That it's a different level than a company. And we also think about issues around transparency and accountability because we want to make sure that the government is actually doing what it is seeking to do. And when Cathy just described the procurement of this system, right, and she described it in a way that suggested that the person who had historically been responsible for thinking about the data that was used in making hiring decisions in hopefully a more thoughtful and curated way that didn't just say, well, whatever we did in the past is going to predict what happens in the future, was read out of the equation. And one of the things that I think we have to be really thoughtful about is as government is using technology to assist it in making decisions or potentially making decisions on its behalf, what level of insight does it have into not just the data, but also the biases that may be built into those systems because of the choices of algorithms or the biases that are part of the production process, right? So who is making them? We're displacing one set of professionals, right, in the context that Cathy described, people who were in the business, they're trained as HR professionals, with a different set of professionals who come out of a different culture, right, an engineering culture that may bring a different level of sensibility and sensitivity and commitments to the work. And so we see transfers of this sort happening as we automate. And if we're not really careful, some of the sensitivities that different kinds of professionals might bring to their analysis of data get lost in that kind of outsourcing or procurement of technology to help us do those sorts of tasks.
Yeah, that's great. I mean, I think there's an interesting point here now already that, you know, even well-intentioned people who are building these models left to their own devices or without proper guidance could easily end up reproducing or propagating these issues, and that many of the kind of traditions we have in the professions might not carry over when these questions of how to make decisions are sort of delegated to these other folks. John, I wonder if you could maybe think about this in the context of health and medicine.
Yeah, so the comp that I was thinking about is the Amazon same-day delivery algorithms, which, we're in Boston. It's a very clear hole in where you can get same-day delivery in Boston. It's completely encircled by same-day delivery, but it happens to be tied to a region that is not as able to have purchasing power, right? It's primarily an African-American region, Roxbury, more or less. And so, I work in health, and so I'm interested in the way that the social determinants of health don't really come through in a lot of the data that we capture. And it strikes me that the social determinants of purchasing have some of the same contours as the social determinants of health. And there's very little in health that is as definitive about your future as your zip code. Your genome is way less predictive than your zip code of your health. And it doesn't capture a lot of the kind of data that we capture out of the health system in electronic health records. Doesn't capture how long it took you to get to health care, or the choices that you had to make about going to work versus getting health care, or whether or not you wanted to get food or have your prescriptions filled. And so I think that the same structures that the AI found in order to predict who should get same-day delivery are likely to find and create holes, structural holes in the way that we predict how healthcare resources ought to be allocated and priced. So that's the one that I look at the most, because it's very predictable when you look at healthcare usage. Right, there's a straight line to the economics of the individual and their usage of the healthcare system and their capacity to use the healthcare system. And so it's already a system that's opaque. If you've tried to get your medical records, you know this. So if you take a system that's already opaque, that you have very little right to look at your data, compared to what I can look at my bank data, I can't see anything in my health record. If you have an opaque data system that's sort of vending the records secretly and quietly to AI systems, by moving to the technology, you actually strip out the requirement to consult with ethicists, genetic counselors, health counselors, community systems, and support systems. Right? It's almost a perfect recipe to do the exacerbation that Cathy was talking about.
Thanks, Sean. And Arvind, can I ask you two for an example?
So we've heard, I think, several examples of bias in AI when you put it in a position of power over people, when you put it in a decision-making context, whether it's jobs, criminal justice, health, obviously really important, really great examples. What I've been looking at with some colleagues at Princeton is a different situation, perhaps a more subtle kind of bias in AI's perception of the world. And I think this is important as well because AI increasingly mediates our own interaction with the world, affects how we perceive the world through search, through natural language translation, through automated computer vision systems that label things for us, through voice assistants on the phone, yada, yada, yada. So what happens when there are biases in these contexts? To understand the difference, let's go back to human bias. Once upon a time, maybe we would have naively believed that once we had equality for everyone in the eyes of the law, then equality of opportunity would automatically result. Right? Well, not really. Today, we know how strong our implicit biases can be, biases that we're not even necessarily aware of, but which affect our actions sometimes. So we started to look at implicit biases in AI. We came up with a version of the implicit association test for the machine. And specifically, we looked at this in the context of a popular natural language processing technology called word embeddings. What are word embeddings? It's a simple concept. You train these machine learning models using text on the web, and it builds up an understanding of the relationships between words. That's what it's about. Now, when we talk about implicit biases in people, we know from 20 years of research in psychology and cognitive science that many people, perhaps most people, subconsciously associate women, for example, with the arts and homemaking and families, and men with science and math and careers and so on. We found a way to interrogate the machine for exactly those biases. And surprise, surprise, we found that it behaves exactly in the way that humans are documented to behave when faced with these pairs of concepts. So that was one we found. Another was racial biases. The machine, just as humans, these word embedding techniques considered European American names on average to be more pleasant than African American names. So what can be some of the consequences of this? After our paper came out, Rob Spear at ConceptNet, I believe, looked at training a sentiment analysis system just to show the effects of this on a corpus of restaurant reviews. And what he found was that the system picked up, just based on text on the web, that the words Mexican and the phrase illegal immigrant often occur in proximity to each other. And so it picked up that the word Mexican is somehow related to illegal and therefore must have a negative connotation, and as a result was ranking Mexican restaurants lower. Right? This is an example of a very subtle kind of propagation of bias in AI through several steps. And where it originates is just AI's perception of the world in the models that we built. So that was one example that we did that was really instructive for me in thinking about this. Our paper appeared this year in the April issue of Science, if you're interested in looking that up. I'll just end with one more related example to this, and this is something you can go online and look up right now in Google Translate or Bing Translate or something like that. Again, these AI systems replicating patterns, as Cathy said, very good at picking up patterns, not just in text, but through that, patterns in our world, disparities that reflect our history of injustice and inequality and disparity and so on. So here's an example. The Turkish language, and many languages like it, don't have gender-neutral pronouns. So a sentence like "O bir doktor" could be either "he is a doctor" or "she is a doctor." But when you translate that to English, it's going to come out "he is a doctor" every time. You try it with nurse, it's going to come out "she is a nurse" every time. And these stereotypically gendered translations that the machine automatically produces almost perfectly reproduce the labor statistics that we have in occupations in our society, in our country. So very complex pathways. They affect AI's perception of the world, and in turn, they affect a variety of applications that we're building using natural language technologies, using vision technologies. So that's my provocation for you.
Thank you, Arvind. So I want to now turn to the question of what can or should we do about this? We've already heard about the problems of sort of not even being able to necessarily recognize the bias, as Cathy was mentioning, that there are certain variables that are deeply important to be able to recognize, for instance, the social determinants of health that might be absent. And I think Arvind did a really great job now, too, explaining that when we rely on kind of cultural products like the language on the web to learn, to teach machines how to understand the world, that they're very likely to inherit these kinds of stereotypical associations. And that it's unsurprising then, too, that the criminal justice system, as Deirdre was mentioning, might suffer from similar problems. So I just would like to turn now to this question of what we can, what is already happening to address these problems. What are our possibilities here? Maybe we can switch up the order. Does anyone want to start?
I'll start.
Okay, Cathy.
So I think, because I wanted to jump off of what you were saying, Arvind, that implicit bias is everywhere. Like literally every time we look for it, we find it. And that's why, when I told you it's a thought experiment, I use Fox News as an extreme example. But the truth is that same basic idea happens everywhere. Anytime you automate something that used to be a human system, you're going to pick up all the implicit bias that the human system contained, always. So how do we circumvent that? And so I'm going to give you a really wonderful story about what actually happened with orchestra auditions. And some of you might have heard this, but they noticed that orchestra auditions were really nepotistic. This is a bias. The conductors would basically choose the students of their friends, things like that, or their own students. So they decided to do better. And what they did was they put a curtain in between the listeners and the auditioner. And by the way, at the beginning, they noticed that the curtain was showing feet, so they lowered the curtain to the floor. They didn't want to know whether it was a man or a woman. And then they even noticed that they could hear high heels on the hallway in, so they put a rug into the audition space. And not only did they get rid of nepotism, but the number of women went up by a factor of 5. And I want to say, like, huge success, but what did they do differently from what I was telling you with the machine learning algorithm? Well, it's actually the opposite of a machine learning algorithm. Machine learning algorithm basically says, throw the data at a wall, look for patterns. Assume the data is perfect, in other words. Data is perfect, just find the patterns in the data and replicate them. The orchestra audition was the opposite. It was saying, what do we care about? Music, sound, that's it. That was the first thing they did. What do we care? What are our values? The second thing was, don't tell me anything else, because other things can be a distraction. And we see that with implicit bias studies, that if you have equally qualified people, but you also have information about their class, their gender, or their race, it will be held against them. So only look at their qualifications. Decide what those are and forget about everything else.
Well, I'll just jump off of that, which is I think one of the lessons is that this is not a problem that was arrived at simply. And it's not likely to be a problem that we have a simple solution to. And so it's not just that they blinded, but they were iterative. And so, starting with the idea that you're going to have to correct the bias iteratively, that it's probably going to be an intersectional kind of problem that needs technical elements, policy elements, governance elements, and then adjustment, right? That's a really good mindset to be in, because if they had started with the curtain solves everything, right, they wouldn't have gotten the results that they did. And so that's, I think, the mindset that we're going to iterate all of these elements, and they're going to be designed to play together, right, to help create something that trends towards fairness, right? That's, I think, is as important as any of the first steps that you take is the idea that you're not done. You're never done.
I just want to add, though, making yourself blind to characteristics isn't necessarily the right way to make sure that you're not building in bias, right? That bias can be encoded in things that might otherwise look quote-unquote neutral, right, as you were describing, and it's only by having those attributes, right? We all understand that we collect data about race and gender so that we can police, right, to limit discrimination. And so by blinding ourselves to those characteristics, in that example you just provided, you would lose data that was necessary to police and make sure that people were being treated in ways that were fair under some definition. And so one has to be careful when we think about the data that's necessary to look at and to protect against certain kinds of biases, that it's not always blindness that we should be seeking. In thinking about strategies more broadly, though, I think there's a bunch of really important things that we ought to be thinking about. One is holding people accountable for the tools that they use, right? And so in the example that I was talking about with the Compass software, the idea that a government can be procuring a system whose code is proprietary, that there are limits on how they test it, where they're not sure, for example, how an important attribute such as gender is being used. Is it being used as a factor, a data element, or is it being used to norm the results? That's a really important difference, right? That they could procure a system that had been trained on a national sample and never examined for whether or not it stood up in a local application, right? Like, that's just bad data science, but it also has enormous implications for the quote-unquote fairness of the results that are produced. And certainly those who are using tools, even when they're math, even when they're algorithmic, have to be held accountable for the tools that they choose. And it can't just be like, oh, well, it's a black box, right? That we have to think about ways in which we ensure that those black boxes are tested for the values that we want to carry forward. And that's going to require different kinds of professionals, different kinds of review, and different kinds of technical approaches. We're going to need, and I think Arvind will probably talk about this, that we're going to need algorithms that help us police algorithms and other sorts of approaches that help us ensure that our systems are producing the values, not just the results that we seek.
Thank you, Deirdre. You set it up perfectly for me, I think, in terms of what specifically machine learning researchers can do. And here's one recommendation. I want to suggest that we should get away from what I call the accuracy fetish. And what do I mean by this? Some of you may know this better than I do, but some of you may not, so you might find this interesting. Here's a major way in which progress in machine learning research happens today. The community tends to agree on what are the important data sets, benchmarks, and particular machine learning tasks that we want to make progress on, what are the baseline scores to beat, and that kind of thing. And then each year there's a competition where hundreds of teams from all over the world try their hand at beating those scores, at beating whatever is the current best score. There are widely known benchmarks and data sets for this kind of thing. A classic one in language processing is called the Penn Tree Bank. A more recent one in computer vision is called ImageNet. Some of these might be familiar to you. And so this has worked pretty well. It has a lot of advantages. It allows you to know at any moment in time which group of algorithms is performing really well. It allows you to quantify progress. It's great. On the other hand, the downside is that when you've got the whole community almost one-dimensionally focusing on these competitions, structurally it becomes very hard to address bias. Because if you're going to focus on factors other than the one accuracy metric, you're not going to win next year's competition. Right? And it's worse than that. A lot of the time, even these training data sets, these benchmarks that have been created for this purpose, themselves incorporate and embed our historical biases and prejudices. And so doing well on those benchmarks necessarily means reproducing that bias. So that's kind of the situation that we're in today with the process, the way in which machine learning algorithm and model development happens. And I want to kind of try to encourage us to get away from that a little bit. Think about a more multidimensional way of evaluating how well we're doing with our algorithms.
Great, Arvind, thank you. So I also would like to maybe try to dig a little deeper and talk about some of the kind of technical and policy proposals that have already been floated about these ideas. So we've kind of talked so far at sort of a higher level about what we might do, generally speaking, but I'd like to, reflect, because there has been, I think, really interesting developments. And in particular, it might be worth reflecting on what are the challenges of adopting and using these new approaches? What needs to be overcome in order to adopt them? And so I wonder if I can ask anyone on the panel just to maybe offer the audience some sense of the work that's happened in the past year, for instance, in this area.
So I think one of the initial responses to concerns around quote-unquote black boxes, right, is this statement, we need transparency, right? We need to be able to look at the code. And quickly that has kind of fallen apart. People are like, well, any talented programmer can hide an awful lot in the number of lines of code that are in that machine, and the way in which one algorithm interacts with another algorithm might not be obvious even after some careful examination. So we've seen the conversation turn to issues of explainability and interpretability, your own work looking at the concept of inscrutability. And those concepts, there's lots of different levels in which we can look at them. I had mentioned the fact that many of these systems are proprietary, right? And when we think about a piece of code that's being used, and I can talk about this in kind of systems that are not about AI, right? So people voting, using technical systems to vote, right? The idea that there isn't an ability to scrutinize that code, whether it's literally looking at it or doing different kinds of testing, requiring that it be built using languages that we can actually develop formal proofs off of, right? That there are different ways in which we can begin to both constrain and interpret and test. And there's been a whole range of work coming out of the technical community on all of those issues. I would say the policy community is somewhat behind in that there's a pretty robust conversation now about the question of what does it mean to explain to people the logic of an AI system, right? How is it thinking, and what does that require? And if we want people, not just in the context of bias, but we want people to interact safely, right, with machines, they're learning about us all the time. How do we learn about them so that we can interact with them? And that requires us to think about what are the assumptions of the models? What are the limits of the models? What are the biases that might be built in intentionally? What are the biases that might be a product of the data, the limits of the data, the collection processes of the data? And I think one of the areas that is right now underutilized that we might think about is the whole body of work around reproducible research, right, which has struggled with a similar set of ideas about how can we actually understand the results. And so I think that there's some disparate bodies of research that we need to start to knit together.
I'm going to jump in and like from a different angle, but building on that. So another example I talk about in the book I wrote about this stuff called Weapons of Math Destruction, a little plug there, is personality tests, also about getting a job, right? Personality tests. So there was this one personality test which we suspect embeds an illegal aspect of what is actually a mental health exam called the 5-factor model, also called the Ocean score. It's embedded in this Chronos personality test, we deeply suspect. Basically, that's the jurisdiction of the EEOC, right? And like the EEOC is a regulatory body that, well, they need to know how to prove this, how to build evidence that this is actually constitutes a mental health exam. And I should mention that 70% of people in this country when they apply for a job, have to take a personality test before they get an interview. This is a huge deal. If these personality tests have illegal elements in them, we need to figure that out, right? But I'm just saying, even though it kind of looks pretty obvious, it's still a big hurdle for the regulatory agency in charge to like make that case legally. And it's just like this technological divide problem, which will be helped once we have better tools and better ways to understand AI. But right now, it's difficult.
Yeah, I mean, one of the things we're seeing in health is there's a couple of different factors. One is that there's been a sort of a generic movement in the patient population towards rights to your data activation. There's been a sort of long, slow policy slog towards having it be illegal to block your data flowing back to you. And the NIH has also put together a multi-million dollar, hundreds of millions of dollars project over 10 years, trying to create a million-person data set that is 75% people who've been underrepresented in biomedical research historically. And then to make that resource shareable so that it's available as a training set in a democratized way. There is, Verily, which is part of Google, is part of the project, but they're going to be part of a collective governance structure. And so it's going to be really interesting to see if, I mean, we know the limits of the inclusion in the data set because it doesn't capture the social determinants of health. But just beginning to have an AI system that's in a collective governance structure that includes representatives of the cohort at a significant level, that's overseen by an independent review board and an access and a resource access community, that's a pretty new way to do this. And so that's, in the last year or so, that's probably the biggest thing that we've seen in health, beyond sort of the generic technocratic application of AI to things like image detection. Right? This is the first time that we're dealing with it in a cultural context.
Thanks, Sean. And Arvind, to close us out, I wonder if you can kind of talk a little bit about the difficulties or kind of dilemmas involved in intervening. What makes this actually sort of challenging and even possibly unclear about what the right thing to do is?
So if I'm going to close this out, I want to do it on a more positive note. So let me say this. Changing your question slightly, Solon, I think one way to make progress would be to appreciate that bias is not only a danger for AI, but also an opportunity. Because one of the things that machine learning technologies can help us to do is not necessarily replace human decision-making, but instead shine the light on biases in human decision-making. And let me give you an example of this. One of my favorite examples of human biases that are really subtle, you'd never expect, is a study out of LSU that looked at judges' decisions depending on whether or not their college football team won or lost the previous night. Crazy, right? It's not a thing you would ever think of until somebody looked at the statistics, looked at the data. And a lot of this research is being done using machine learning. And the papers show that judges are harsher in their sentences if their favorite team lost the previous night. Right? And so the answer, of course, is not to replace judges with AI, but instead to use machine learning to at least understand the way that humans make decisions and perhaps have automated augmentation of the way we make decisions, of automated input into human decision-making, and of human oversight over machine decision-making. And so these can be paths forward.
Thanks, Arvind. So I would hope that everyone will join me in thanking the panelists. This has been a great conversation. So.
Thank you.
Go that way.